Imagine being in a massive library where every book isn't sorted by title or author, but by how closely its theme resembles the book you're currently holding. That's the essence of what a vector database does in artificial intelligence, and it's revolutionizing how machines manage and understand massive amounts of information. But what exactly is a vector database and why is it so pivotal in AI? At its core, a vector database is a system designed to store and retrieve data represented as vectors, mathematical objects that encode information as arrays of numbers. These vectors aren't just random numbers. In AI, they're often derived from complex algorithms like neural networks, designed to capture meaning, patterns, or relationships. For example, if an AI is working with text, each word or sentence might be converted into a vector that encapsulates its semantic meaning. Similarly, in visuals, an image can be transformed into a vector representing its features, colors, shapes, textures, and more. Now, here's why this matters. Traditional databases, like those storing rows and columns of data, work for structured information, names, addresses, or even basic categories. But the world we're trying to simulate and understand with AI isn't structured. It's nuanced, messy, and highly contextual. Enter vector databases, which thrive in this unstructured environment. They use vectors as bridges to understanding the relationships between words and sentences, connections between images in a gallery, and even patterns locked within sound files or genetic sequences. Imagine you type beaches at sunset into an AI model. Rather than scanning for those exact words in its database, the system calculates the vector representation of your phrase, comparing it with millions of other vectors. This makes vector databases essential for applications like natural language processing, recommendation systems, or even complex search engines. Companies are using them to supercharge AI's ability to detect fraud, personalize user experiences, and even uncover scientific breakthroughs buried deep in data. However, there are challenges. Vector databases handle incredibly large amounts of data, and finding the closest match among billions of vectors demands exceptional computational efficiency. That's why innovations like approximate nearest neighbor search and specialized hardware are driving advancements in this field. As AI continues to evolve, vector databases are becoming the beating heart of systems that truly understand context and meaning. They're helping machines think about the world in a way that's closer to how we do, through connections, patterns, and relationships. And perhaps most excitingly, they're opening doors to discoveries we haven't even dreamed of yet.